Okay, good day, students. I just want to quickly use this video to help some of you that might be writing an exam very soon. This question 3, he said, show a figure 3.1 shows a weather station in South Africa. So we are just going to mention the names of those instruments. So I will go to those instruments now. So I want to believe you are seeing my okay. Okay, so I managed to rotate it. So this is the uh, first instrument that they want you to label. So this is Stevenson's screen. Stevenson screen. Well, I will not be writing because I want this video to be as fast as possible. So if you don't get the words clearly, you can rewind and hear it again. Stevenson screen. So it is used basically to house sensitive weather instruments. When you talk about sensitive weather instruments that can easily be affected by sun and rain, like thermometer, like barometer, like hygrometer, sundial. Those are the instruments you have in Stevenson screen. And it is painted white to reflect heat. That's why it is often painted white. And it is raised above the ground, as you can see. It's raised above the ground, about 1.2 meters above the ground, so that it doesn't absorb heat. The instrument in it do not absorb heat from the ground. It is roofed, of course, to prevent rain and sun from coming in directly, and that will affect the reading as well. Then it is slated. In other words, it has some holes by the sides. You know, you have holes here and the other side to allow air move in and out for proper ventilation. That is so. Those are the things you should understand about Stevenson screen. Here, B is you have two instruments here: anemometer, cup anemometer. This is cup anemometer, and this is wind vane. So, cup anemometer measures the speed of the wind, while wind vane measures the direction of the wind. So that's what two of them measures, and you can see it is connected to this. So I think the readings will be processed here and it will be transmitted through this cord. This is a cord. This is a cord into a form of device that is kept here to keep the reading. A form of digital devices inside here that will be. So this D is transmitting data into here. While this C is a rain gauge. Rain gauge. Some people call it rain gauge. So it contains of a funnel and a cylindric in the form of cylinder. So it gathers rain here, and the rain is now measured using a calibrated cylinder. And in this case, I think the rain can be measured as well with this cord. Maybe it's a form of digital rain gauge. So I think it will be measured, then transferred through here and brought in here as well. Okay, so those are the instruments. I believe you are fine with that. Okay, so let me go back to the remaining questions. So I believe I'm done with that question. Clouds are observed and described but not measured by instruments. Figure 3.3 shows clouds in Kazakhstan. So we are to describe cloud X and cloud Y. So let me go back and just let's look at the cloud. So this is cloud X and Y. As you can see, S is a cumulus cloud, cumulus, C-U-M-U-L-U-S, while Y is a cirrus, S-I-R-R-U-S. So a cumulus cloud is a cloud that is thick. Cumulus from the word cumulate. So it's kind of thick, it gathers, the cloud gathers, forms a heap, and it piles up kind of, it's fluffy. thick, fluffy gathers. And this cirrus is thin. You can see that it's thin and it's far into the sky. This one is farther into the sky and it's thin, wispy, wispy, wispy. So those are the basic description you can give. And what is the similarity? Both of them are whitish. Both of them are whitish. So those are the two types of cloud you have here. The third one is not here. Stratus is not here. Okay, so let me be fast with this. So that's the format question. So if you all those things I mentioned, if you mention them, you'll be fine. So figure 4.1 shows natural vegetation in two areas with very different climates. Describe the natural vegetation in figure 4.1. Okay, so let's go back to figure 4.1. I need to be sharing like this, else it will not, I might just be talking and it won't show what I'm describing. So this is figure 4.1. You have to describe this vegetation. Well, what can we say about this? The grasses are short. The grasses are sparsely distributed. Some are found within rocks, while some are found on the ground, in the background. But generally, the grasses are short and there are not many, they are not much, sparsely distributed, found in between rocks, bare rocks. The rocks are brownish in color. So this is obviously rain is lacking this climate here. So that is the basic description for that. And for the second one, of course, how do you explain this? You can see that there are a lot of vegetation here, very rich vegetation, luxuriant, rich, lot of trees and grasses. You can just come in and talk about the different layers of tropical rainforest, where you have the emergent. Here are the emergent, the tallest trees. Then you have the canopies as well. The canopies are these, they branch into each other. Then underneath them, you have the under canopy, those ones that don't have enough access to the sun. Under canopy and forest floor. Under canopy is also called understory, forest floor or shrub layers. Then there is presence of water in the background. So there are a lot of water for proper, irrigation of this plant. That's why it is very rich. That's why it's luxuriant. Obviously, rain is much. Rain is abundant here. So all of those things I've said, if you can put them together, it will fetch you all your marks. Lot of is luxuriant, is rich in vegetation. There is emergent, canopy, understory. There's water in the background water in the background, which helps. So rainfall is much here. Okay, so let me. I hope I'm not too fast. So I've just described the two vegetations there. I think one is 4 marks. So 4 clear points each, and you'll be fine. Okay. Figure 5.1 shows the word distribution of areas of equatorial climate. So they want you to pick which of the two following statements describe the area of equatorial climate shown below. So from here, so let's pick the first one. They are south of the Tropic of Capricorn. Can we say that? Let's go back. South, where is Tropic of Capricorn? This is Tropic of Capricorn here, 23.5 degrees south. So look at the equatorial climate. Are they south? No, they are not of it. So that number one is wrong. Number two, they lie on the two tropics. Can we say that they lie on the two tropics? This is one tropic. This, well, no. So let's move on. Number three, they are in every continent. No. They are within 20 degrees of the equator. Let's check. Yes. Look at 23.5 degrees north, 23.5 degrees south. So these are found in between. Of course, if you have to strive for accuracy here. If this 23.5 degree north, so 20 will be somewhere around here. So 20 degree north and 20 degrees south. So I think that one is correct. That one is correct. So this one is correct. You tick it. They all reach a coastline. Do they all reach a coastline? Let's check. This reach a coastline. This reach a coastline. This, yes, this is a coast. And here too, they are all coasts. So they all reach a coastline. That is correct. They all reach a coastline. So you take this and this. Okay. Now let's move on fast. Which three of the following statements best describe the climate of X as shown below? Of course, looking at this graph, you can tell that this is a tropical rainforest climate because there are a lot of rain. You can see there are a lot of rain as shown by these bars. The least rain here, look at the least rain is about 200 mm, which is very high. And look at the temperature. This shows the temperature. So what can I say about temperature? The range is low. The highest temperature here should be like 27 degrees, and the lowest is like 25. So what's the range? 2. So with that, there is a low annual range of temperature, and the temperature is high. The least temperature is about 25 degrees, which is high. So there is low range of temperature, but there is high temperature throughout the year. I want you to understand the difference. High temperature throughout the year, if you look at January, February, March, no month is less than 25. That's a high temperature. And though the highest temperature is about 27 degrees. And look at it, there's a lot of rain. So a lot of, yes, as shown by that bar. So let's check it. It's a cold season? No. July is the hottest month. Let me quickly confirm that. If July is the hottest month. So how do you know that? That means the month with the highest temperature. So this is July. Is July no, July is not the hottest month. You can see it from that. There's a low annual range of temperature, correct. This is correct. I've mentioned that earlier. Because the range there is about 2 degrees. Temperatures are high throughout the year. Yes, I've mentioned that also. So these two are correct. And one more. January is the coldest month. I don't think so. The coldest month should be the month with the lowest temperature. So it's not January. I think it's July. And January, the annual rainfall is low. No. January is the driest month. No. October is the wettest month. Yes. No. Let me check it. This October. Is it the wettest? No. The wettest month is May. You can see that more rain in May than October. So there are 2 wetter seasons. Yes. This is the third one here. So how do I know that? Look at it. The highest rain is found in May, then it drops, then it picks up again, reaches a peak here, then drops. So there are 2 peaks. That's what it means. So we have 2 wetter seasons, 2 peaks. So that is what that means. So those are the 3 you pick. 1, 2, and 3. Okay, let me run. The vegetation, so you are asked to give, what is the name of this? Name each. The continuous layer of leaves and branches formed near the top of tall trees. That's canopy. Continuous layer of leaves and branches formed near the top of tall trees. Near the top, not the tall tree. The tall trees are emergent, so near them is canopy. The pointed ends of leaves which help to get rid of excess rainfall. That's drip tip. D-R-I-P, then T-I-P-S, drip tips. It helps to shed excess rainfall for leaves in tropical rainforest. The root which supports tall trees in the soft soil, it is called buttress root. B-U-T-R-E-S-S, buttress root. Okay, so this last question. So they want you to state the percentage of water used in Egypt that's obtained from surface, rivers, and reservoir. I think they've already mentioned it in the question. So, but if you look at it here, this is a pie chart. Everything is 360, but they want it in percentage. They just want you to find the percentage of this. So get your protractor, measure this angle. Whatever you get, put it over 360, multiply by 100. That will give you whatever it gives you. So from here, I know it's going to give you something within 85%. 85%. So the answer to this is 85, between 85 to 89%, or between 80 to 85%. That's what's going to. So you can. That's how to work. I believe every student preparing for exam should be able to do that. Give two problems for Egypt of relying on groundwater for water use. Now, if you look at this, this question I'm treating is paper 2, the other side of paper 2. So most of your answers will come from the images that you have been given. Now, saline groundwater, that means that the groundwater is salty. So that's a problem. That means when they extract the water, they need to treat it, they need to remove the salt content before it can be used. That's one. There is deep groundwater. So that means that it's going to cost a lot of money to dig deep and get the water out. So that's another challenge that is going to. So they say two problems. So it's too deep and it's salty. So that means it's going to cost a lot of money. And you need to, after getting it, you still have to treat it. Explain how groundwater is obtained. How do you get groundwater? By digging, by drilling into where the water is. You drill a hole into where it is, then you pump it out. Use a pumping machine to pump it out. So that is what borehole concept is all about. You dig a borehole into the underground water, then you pump it out. Name one source which could provide a large quantity of water for desalination in Egypt. I've been using that word desalination. I don't know if everybody knows what it means. It simply means to take salt out of water. So which from the graph, from the image, if you look at it very well, there's Mediterranean Sea, there's Red Sea. So Red Sea will be useful for Egypt. I think Mediterranean Sea as well, because they are salt water, but they can be treated. That's what desalination is all about. So what's the advantage? What is advantage for a country needing to use desalinated water? What is advantage? You need to treat it. You need to build a plant to treat it, and that's going to cost money. You need to build a plant for it. The Grand Renaissance Dam was due to be finished in 2017. The Egyptian government protested about Ethiopian plan to construct it. Explain why Egyptians will oppose to the new dam being built. Well, if you check here, look at River Nile. This is the Grand Renaissance Dam here, this point, and it's being built by the Ethiopians. So this is part of Ethiopian land. Once this dam is built, it's going to reserve a lot of water within Ethiopia. That's a reservoir, and the flow of River Nile will drop. So you can imagine the flow of this Blue Nile will drop. And if the flow drops, it's going to affect Egypt, because Egypt relies heavily on River Nile for a lot of things. They rely on the River Nile for farming, for irrigation farming, and that is the bulk of the economic activities they do, and even for their own domestic use of water. So they will be opposed to it because it will prevent free flow of water into Egypt. And that will affect their farming activities and their domestic use of water. So just explain that it will affect the flow of water from River Nile into the areas in Egypt, and that will affect their farming and their domestic use of water. That will give you the full 2 marks here. So I believe that this video has helped somebody to have 1 or 2 ideas of what to do. If you are doing this part of the IGCSE question. So thank you very much for paying attention. If you need to reach out, maybe you are watching this outside Nigeria or anywhere, and you need some tutorials in geography, you can reach me on, let me put my email here. You can reach me on dayolawa@gmail.com or Facebook. So that's my number. If you are calling from outside Nigeria, you just attach 234 24651 So those are my contacts. You can reach me through any of that. Thanks very much for being part of this. Bye bye.